transformations take a shape and move it around. You'll notice this one that said example A here. The red figure from the blue figure is a rotation. You can kind of see how it's like I can draw a little line. This point goes to this point. This point goes to this point. This point goes to this point. Okay, I saw somebody come in. All right, welcome guys. We're talking about, okay, I think somebody's in the wrong period. Paula, I think, yeah, this is a 135 day. But maybe I got my roll sheet wrong. Anyway, it like goes around a little point here. This one is a reflection. And if you draw a little line like this, it makes it clearer than it is, except for I got it off by a little bit. There. See how it's a reflection right across there? Okay, so here's the class participation part. Number 1, is it a translation, reflection, rotation, or dilation? Tell me what you think in the chat. Number 1 here. Which of these? There's 4 choices. Translation, reflection, rotation, or dilation. Okay. I got one person responding. Who else is going to respond? Come on, be brave. Nobody can see what you say. Come on, guys. Just one person is willing to participate? That's so sad. 2 people. All right, goody. 3 people. Oh, come on. Let's hear a few more. I got a vote for translation, a couple of votes for reflection, 1 vote for dilation. Which one is it? Come on, guys. Try. Just take a guess. You learn more if you do. Number 1 is, in fact, a reflection. And you can tell, see how, if it has that was a little sloppy. I'm going to do that. Try it again. Oh, undo. There we go. Let's try it again. See how there can be a line right down the center and it's symmetrical across it? It's a reflection across this line. It's like you could fold it. All right. Actually, so a couple of you said dilation. This one is the dilation. Dilation, like, you know how when they talk about your pupils dilate, when it's dark, they get bigger. Dilation is about things getting bigger or smaller. We'll have a section where we learn about that. So this one's dilation and this one's rotation. How about number 2? Tell me what you think number 2 is. Waiting to hear. Waiting to hear from you. What do you think number 2 is? Come on, guys. You're slowing the class down. Come on, try. No one can see what you write. I got a correct answer from Emily and from Caleb and from Jordy. Not saying what it is, but they were all correct. Okay, so somebody gave me, let me talk about an incorrect answer I just got here. This one is a translation. Oh, man, I need the new thing to work. This one is a translation. Translations are when you move the whole thing a certain amount over and a certain amount up or down. That's the part, that's the one we're going to do today. We're doing translation today. But we'll cover all 4 of these in the class. Now, let me clear this screen. And let's take a look at the problems we're going to do today. Check this out. So let's get a little bit of vocabulary here. See how this says A, and this is A with this little dash. You pronounce this A prime. It's not a 1, it's a little dash. So this is triangle ABC, and this is triangle A prime, B prime, C prime. This one over here, this one is called the pre-image. This is an R, pre-image. They may or may not put a dash there, but I like to put it for emphasis. This is the pre-image, and this one is the image. Oh, come on. This one is the image. It is the result of the pre-image and the translation. So what you'll notice is that there's 2 ways of thinking of this this change. You could think that you went in a direction like this from A to A. See how everything could go like this? But we could break it down. Let me change colors here. We could break it down into you moved a certain amount over and then a certain amount up. That's how we define this translation. And that happened the same amount over and the same amount up for all 3 of these. Same amount over, same amount up. That's what makes it not change shape. The fact that everything moved the same amount. We call this rigid motion. The thing didn't get distorted or anything. It stayed the same shape. It stayed rigid. So we define these, we describe these things in a little rule here, an arrow rule. If you, clear my drawings, scroll down here. Let's see, we call this translation a vector. So you can, this is the little arrow I talked about first, and that you could break it into instead of one diagonal motion, we can think of it as 2 motions, one that's in the horizontal and one that's in the vertical, which is great for us because we got this coordinate plane. It's easy to talk about these numbers because they're kind of right on the graph. Like this vector here, this one, we would go, let's see, that's 3 in the positive x direction and 4 in the positive y direction. We'd write it, that's why they write it 3, 4. Now you'll notice they use a little, instead of curvy lines here like it was a point, they use these. They're a little bit different. Some other books will use, and the way I do it on the test, I don't have these little things, I'll do it this way, but it means the same thing. And how they write it is an amount that's added to the x and the y. Yes, Caleb, this is our next subject. Jordy, you were right. The number 1 was reflection. You were correct. I'm looking back at your chats there. Let me clear this and move forward. Okay. So here's a typical problem. So here's the pre-image right here, A, B, C, and they're translating it to make A prime, B prime, C prime. You can literally take these points. Let me right here. I can take the coordinates of A. That's 0, 3. Right, this is a point. And I'm going to take this. This is saying, as a matter of fact, we could write it this way if we wanted. We can write this vector notation, we could write this way as x, y becomes x plus 5, right? That's the 5 there, and y minus 1. So whatever x is, we add 5 to it. Whatever y is, we subtract 1 from it. So fine, I'm going to take the 5 and the negative 1 and make a new point. 5, 2, and that's where the new A is, right there. I can do the same thing with the original B and get the new B. There's the original B, right? I'm going to take the 5 and negative 1, 7, 3, and there it is. I can do the same thing with C. I'll take the 1, 0, and x gets 5 added to it, y gets 1 subtracted from it. So that's 6, negative 1, just like that. So we can also go the other direction. If they give us the translation, we can figure out what the rule is. So, get a different color here. So if we're going from A to A prime, the x direction, notice how we went back 4. This is negative 4 in the x direction, but positive 1 in the y direction. So if we're writing it in the vector format, we'd say negative 4, positive 1. If we were writing it the other way with the arrow notation, xy becomes x minus 4, y plus 1. Means the same thing. Yeah, no, I agree, Caleb. This is not that complicated. I think, and it's kind of fun. Yeah, I like this. I like translations a lot. All right. So, okay, so let's take a look at another one here. They say name the vector and write its component form. So if so notice you're starting at B and going to K, right? And in this case, K is the exact point where it ends. The arrow means not that it looks like a ray, but the arrow means that it goes from this point to that point. It's a direction. So it kind of looks like an array. We use the ray notation. We'll use that little arrow over it, but it doesn't actually mean array. It means a vector. So if I'm starting at B and I'm going, I should use another color here since it's already green. I'm going, how many? I'm going 1, 2, 3, 4, 5. This was 5 in the negative direction and 2 in the positive y direction. So that's negative 5, 2. Right? If we're going from B to K, that is my vector. So notice, just be careful here if you're trying to do all these problems. These are separate. This one had to do with just this. This new one, they gave you a new vector here. And if you were going to use that, fine. You just add these to the x and the y. No big deal. Let me clear that. Close that. All right. I talked about that. A rigid motion is a transformation that preserves length and angle measure. Another name for rigid motion is isometry. Isometry. It makes me think of isometric exercises. I don't know how those are related. That's interesting. So a composition theorem, a composition of two more rigid motions is also a rigid motion. This is kind of obvious to us. Like I can, if I took PQ and moved it here and then moved it here, it's the same as if I just moved it here, right? It didn't get if it didn't get stretched by going this way and this way, it wouldn't get stretched by going automatically this way. And that's the idea, is it's a rigid motion. It hasn't gotten stretched or distorted or anything. And we care about that because it's part of our definition for things being congruent. Because later on, we're going to talk a lot about how to know if things are congruent. Things meaning triangles and stuff. All right. So here's a composition. They started with RS, and then going from here to here. Notice how you go, draw this again. We go there to go from S to S prime. That's 1, 2, 3, 4, that's 5 and -2, right? There's the 5 and -2. And then to go from here to here, that's one. I'm going to do a different color here just for emphasis. 1, 2, 3, 4, -2. So this is -4 and -2. That's what this is and this is. Those are the two translations. They gave us a solve real life problems. You're designing a favicon? What the hell is a favicon for a golf website? I don't know what a favicon is. In image imaging program, you move the red rectangle 2 units to the left and 3 units down. Then you move the red rectangle 1 unit up. Rewrite the thing as a symbol translation. Okay. All right. So here's their points. If you have two, here's one of the translations. You're just adding the two of them. -2 and +1 makes -1. -3 and +1 makes -2. They just combine the two, the stuff that you added to X to make one thing. No big deal. It seems like they're making it harder than it has. It's later on they're able to be more mathy about it. And there's a reason. Let me put it this way: there's a reason why they are using all this complex language. It does relate to different stuff, but yeah, if you're like, is it me or is this actually super easy? No, it actually is super easy. Okay, so let me stop sharing my screen. Oh, no, wait, I don't want to quite stop sharing my screen yet because I want to show you the test practice problems for this. Okay, test practice problems. There are already a lot of practice problems up for this one. I haven't changed the page here to have transformations be highlighted here, but this is what we're on. Oh, and I have these in I got to switch those around because we're doing 4 next. All right, so just check this out. Translations. There's lots of different ways of me asking these questions. Look, there's actually 9 different ways, but they're all really easy. Check this out. Here in words, graph the image using the transformation given. 1 unit up. Oh, look, it's 1 unit up. There's 3 units to the left and 4 units up. Reminder, the black one is the pre-image. It's the one you started with, and the red one is the image. It's the answer, is the image. I might ask the question like this. Find the coordinates of the vertex of the new thing with that translation. So there are the points. Notice they said 3 right and 6 down. So if I take B and I go 3 right and 6 down, 1, 2, 3, 4, 5, 6, I'm right here, which is 0, -2. Not complicated. All right. I will leave you to that.